Hi, everybody. Today we're going to multiply two rational expressions. It's a standard type of a problem in Algebra 2. I turned off my webcam so that we could focus more on the math. I'm going to go through it rather quickly just to kind of show what a lesson is like from my perspective if students get to work with me. Let's just jump right in. So one thing that I do is I color code a lot. I'm going to take a look at the top left polynomial. That one's going to be in red. The bottom right polynomial, that one's going to be in blue when the time comes. Now, if you want to factor the top left, one of the best ways to do it is take a look at the first term and the third term and multiply them together. If I do 2x squared times 21, that is 42x squared. Now, moving forward, I want to find two factors, each of which that have an x that multiply to 42x squared and also add up to 17x. And the factors there are going to be 14x and 3x. 14x and 3x. Multiplying them together give you 42x squared. Adding them up gives you the 17x. So what I'm going to do here is I'm going to rewrite the top left polynomial in the following way. 2x squared plus 14x plus 3x plus 14x plus 3x plus 21. If I combine these two, I get my 17x, but I'm not going to do that because it's going to have us go back to where we were before. Instead, what I'm going to do here is factor by grouping. If I take a look at the first two terms, and if I take a look at the last two terms, we're going to factor just with the orange. If you ask yourself what's the greatest common factor, it's going to be a 2x. If I take out a 2x, I'm going to be left with x plus 7. A quick check, 2x squared plus 14x, it checks out. Taking a look at the last two terms, GCF here appears to be a positive 3. We always double check. I'm going to have x plus 7. If I distribute this back in, 3x plus 21, it checks out. From here, using other colors that I have not used yet, the binomials here must match. And if they match, we're allowed to move forward and use these, the GCFs, as a binomial. 2x, positive 3, 2x plus 3 in blue, times the repeated binomial of x plus 7, that's going to be the other one. In order for us to do this type of math, the binomials must match, and if they do, the GCFs become a binomial, the repeated binomial become the other one. So we have just realized that if you try to factor the top left, it's going to factor eventually into 2x plus 3 times x plus 7. That's what it'll factor into. So what I'm going to do here is I'm actually going to move this over a little bit, and I'm going to rewrite the polynomial that I had before, the 2x squared plus 17x plus 21. I'm going to rewrite it as what we found before, 2x plus 3 times x plus 7. Erasing my work because I want to make sure that I have workspace for later. If I take a look at, let me do a greenish color here. If I take a look at the polynomial on the bottom left, that can be factored out by asking what are two numbers that multiply to negative 35 and also add up to a positive 2x. That's going to be a positive 7 and a negative 5. So we're going to have x plus 7, x minus 5. Quick double check. If you multiply these two, you get a negative 35, which we have here. And if you add these two, you're going to get a positive 2. And again, the purpose of this video is to kind of show what a lesson is like. It's not necessarily to teach the material. It's just to kind of showcase what a tutoring session would be like for students who work with me. If I take a look at the top right polynomial, which I'm going to do in pink, that is the difference of squares. The difference of squares formula says that if you have a squared minus b squared, that is a plus b times a minus b. Color coding again, if I have my x squared minus 25, that's the same as saying x squared minus 5 squared, which is going to give me x plus 5 times x minus 5. From here, I can rewrite the top right as the x plus 5 times the x minus 5. Okay, continuing on to the bottom right, I'm going to create some space here. If I take a look at the bottom right, remembering the rule from the very first part of the video, we're going to multiply the first term and the last term together. If I multiply 2x squared times a negative 15, that's going to be a negative 30x squared. And repeating the idea from before, we're trying to find two factors, each of which that have an x, that they multiply to a negative 30x squared, and they also add up to a negative 7x. So me thinking out loud here, I'm going to think of 10 and 3. I'm going to think of 10 and 3, and then they each have to have an x, so I'm going to say 10x, 3x. Now, these two have to multiply to a negative 30x squared. So one of them has to be positive, one of them has to be negative. If I'm going to add them to give me a negative 7x, then it has to be a negative 10x. And just a quick check, if I multiply these two, I'm going to get a negative 30x squared. And if I add these two, I get a negative 7x. So it checks out. From here, I'm going to rewrite as, I'll actually continue doing the work down here, 2x squared. Instead of a minus 7x, I'm going to say minus 10x plus 3x. Minus 10x plus 3x minus 15. Again, if I combine these two, I'm going to get that, but I don't want to do that because it's going to take me to where I started from. Instead, factoring by grouping once more. Take a look at those two, pull out a GCF. Take a look at, colors don't matter. Take a look at these two, pull out a GCF. When it comes to the orange, the greatest common factor here appears to be a 2x. If I take out a 2x, I'm going to be left with x minus 5. Always a quick double check. 2x squared minus 10x checks out. If I take a look at the red, positive 3 for a GCF, I'm going to be left with x minus 5, it appears. Quick check, 3x minus 15, it checks out. Just like before, these have to match. If they do, we're allowed to move forward. Because they do, I'm going to take 2x plus 3, and I'm going to turn that into a binomial, 2x plus 3. And then the x minus 5 that repeats is going to go here. The color coding is there to kind of help guide. We eventually realize that the original trinomial that is on the bottom right, that will eventually factor out into 2x plus 3 times x minus 5. Through factoring by grouping, we have rewritten that way. And I'm going to now take the trinomial on the bottom right, and I'm going to write it in that form. 2x, make that look a little nicer, 2x plus 3 times x minus 5. Again, I'm going through this quickly because I want to showcase what a typical lesson would be like. The pace would be far more slow if we were actually learning the material. All right, so now we're here. We have successfully factored out every single one of these polynomials. Now what we're going to do is look for any factors that are shown in both the numerator and in the denominator, and we're going to cancel them out. If I take a look here, I have an x minus 5 and an x minus 5 that cancel out. As long as one is found on top and one is found on the bottom, they cancel out. If I take a look and see what else can be factored out, it appears that a 2x plus 3 and a 2x plus 3, those cancel out. And, and it's worth noting that the factored out, that the binomials that get canceled out, they can be on other fractions, not the original one. Here we're going across. One more. It appears that there's an x plus 7 that we can cancel out. And now we write down whatever we're left with. The only thing that we have on top is an x plus 5 right here. The only thing that we have on the bottom is an x minus 5 right here. And this right here is our final answer. So I hope everyone enjoyed this brief tutorial. Again, I went through it quickly just to make sure that the process was being shown. I color code, I organize all of my work, and I look forward to helping you and your students in the near future. Thank you.